Yes, Aditya, you continue. Yes, Aditya, you continue. Sorry for interruption. You are actually that disconnected for him. He is rejoining within 2 minutes.
Yeah, I came. Please wait.
Yeah, Janda. Okay, continue.
Probably this is okay now. Right, is it okay now? Is it visible and it's clear?
Yes, sir. Yes,
Yeah,
sir.
it's visible.
Yeah, thank you. Anyway, students, this is about the dissolved nutrients. Mostly, the plant and most of the nutrients will be dissolved in the water, which is highly available to the plants. And plants mostly take only these dissolved nutrients only. Mostly last proportion of the nutrients exist in the soils. Other forms varying availability. Mostly mainly in other forms also, not only in solution forms. You can see in a fixed forms or non-exchangeable forms also it will be taking place. And mostly nutrients which are readily available in a solution form will be mostly uptake by the crops in a field level, and these there will be some imbalance will be appear. So naturally, whatever the non-exchangeable form is, that it will be completely replaced with the soil solution form. Like this, there will be a quite natural balance in the soil. So this will carry out and so on. Like this, there are many things. In technical word, we say that that's the dynamism of the nutrient supply. And we will see next slide about details held on the surfaces. Mostly students, cations, cat means positive charges. Mostly nutrients, mostly soil nutrients are of two types. One is the positive and negative charged particles. The positive is called as the cations, and well, a negative is called as anions. So soil solutions, cation exist. Most of the cations exist in the soil solution observed by on the soil adsorbed. That means will be attached to the soil surfaces, and also they came by the mineral breaking and weathering, and some organic decomposition also will take place. Most of the cation example of nutrients are calcium, so divalent cation, and magnesium also divalent, and hydrogen and potassium. So majorly these are the major important cations present in the soil solution. And naturally these are the held on the clay particles, because clay is an opposite charge, it's a negative charged particles. And cation exchange capacity, students. And also you can see this cation exchange capacity also plays a major role in soil fertility. The cation exchange, it is just in the word itself we mentioned that there will be an exchange of particles will be there. If they will exchange the cations with everything. So since the opposite charge attracted, most of the ions held in the soil is take a positively charged. So uh, the clay particle is naturally a negatively charged particle. So this negatively charged particle will attract the positively charged particles. In the positively charged particles, we can see our nutrients, our valuable nutrients, soil nutrients will be taking place. So this more nutrients will be taking place. So these nutrients will be taking place. These nutrients So the number of cations that held and therefore exchangeable. So whatever the positively charged particles will be held. For example, just for example, hey, hell, this is a clay particle. Naturally, clay particles are negatively charged particles, and our nutrients, say for example, calcium, which is a very familiar nutrient, which is a positively charged. So this will be attracted attracted to the clay particle. So in exchange, it will release some H plus ions. Just a minute. So naturally, so this is what. So naturally, how much charged points are there? We can how much negative charges are there? We can get that much amount of Ca2 plus ions. That means that much calcium we can get. So this is called the cation exchange capacity. Mostly, this is the measure of ability. Here I mentioned it's a measure of ability. So this is the measure. A cation exchange. It is a measure of ability of the soil to hold a positive charge in nutrients. Just now, as I explained, it is expressed mostly. CEC is explained in the form called centimoles of charge per kilogram. That is C mole per kilogram. That is how many cations per mole is attached to the soil. It will completely expressed in C mole per cation. But later on, it was replaced by the milli equivalents. But actually, most of them will be expressed in C moles or 50 milli equivalents per 100 grams. So this magnitude of CEC, mostly the CEC depend upon the texture. Very completely, if you see the loamy particles where the equal proportions will be equal proportion of sand, silt, and clay will be there. There we can say very proper and a good CEC. So naturally, if there is a very high CEC or very proper CEC, we can see we can expect a good nutrition exchange, and this type of minerals present in the percentage of organic matter also. And also organic matter, yes, organic matter is wonderful. Organic matter also Organic matter also plays a major because it's also have a high CEC. So naturally very high CEC means with a good fertility status also we can maintain. As the texture get finer, just now I explained, as a very if we go to the very finer texture, the amount of surface area in each gram of soil increases. This creates a more place for the negative charge can occur as the CEC increases. Yes, students, we go there, if there is a more of particles. For example, students, if you take think this is one cuvette or some beaker or something. If you fill a sand particle here in the small cuvette or some beaker, how many particles it will be there? At the same, just imagine how many particles it will be present. At the same time, students, if you take another cuvette and you fill with only clay particles, and you can say how many particles it will be present here. So naturally, the surface area will be more in the clay particles, students. In clay, you can see more particle than compared to the sand. In sand, it is very less. In sand, it is very less than compared to clay. Clay is very clay. So actually, more surface area. That means more surface area, more negative charge. So more CEC, and ultimately we'll end up with a more nutrient supplying capacity. So this is what as explained in this slide. And later we will see this is what the CEC. So the high CEC. Just a minute. Well, students, overall, coming to this CEC, I will explain very somewhat very crisper manner. CEC, it's a cation exchange capacity. Students, remember, students, all the sand particles, all the soil is completely a negatively charged particle. So our nutrients are whatever the calcium, magnesium, all are cationic form. They will attach to the clay particles. That means the clay is negatively charged. Our nutrients are positively charged, so they will attach. So students, if there is a more negative charge in our soil, naturally more nutrients will come. More nutrients means more the plants will uptake will be very high. So naturally there will be very good growth. So CEC also will play a major role in our fertility status. That's why students, you see, whatever problem we get in our agriculture crops, we always encourage the farmers or our agriculturists to go through the apply of organic matter, because organic matter also contains a very good amount of CEC. It also have a good amount of nutrients will be there. So that nutrients will be available to the plants in a direct manner. And this CEC will be calculated in centimoles per kg. That is a centimoles per kilogram. And later on, even in some literatures, we can see milliequivalents per 100 grams. But naturally, the very famous is C moles per grams. Even if you go for cation, we can see P plus. That is exchange of cations like this. So CEC will play a major role in our fertility status. And coming to the next way, the cation exchange capacity. However, there will be some proper equilibrium also will be there, students. In CEC, there will be a proper equilibrium will be established. If the proper equilibrium, if for some nutritions, or say for example, this is a clay particle. It is a completely a negatively charged particle. Okay, and if you get some positively charged mineral nutrients were attached, definitely there will be some release of some expel of H plus ions, some hydrogen ions, because to maintain the electronic neutrality, then only it will be a proper situation. So naturally there will be a to and fro disturbance will be there. Sometimes also this nutrients will come and fix here. And by moving forward and forward, what will happen? So very first, students, this is the clay particle will be in a negative charged. Very first layer, it will be fixed very thick. But if you go further and further towards away from the clay particle, what will happen? The attraction power of this clay negative charge is very less. So naturally, the plant surface. See, this is a root crop. These roots will observed by the crop. So naturally, the nutrients will be taken away, and plant will be utilized for its metabolic purpose. At the same time, these whatever the nutrients present inside the interlattice structure. Suppose you know what is the lattice structure. So from this lattice structure, it will replace this area. So naturally, there will be a proper balance and proper dynamism will be act. There will be proper equilibrium between the surface and solution area. So this will makes a very important phenomena in our cation surface. This cation exchange is a very important reaction in our in soil fertility, will plays a major role. And we will see next slide, we will see importance of another one, that is called the meaning of mineral. Students, naturally students, in many literatures, or especially in soil science, for pedologists or for geologists, the mineral is something else, something different. For agriculture, something is different. Or so naturally the word mineral has several meaning. Very first, students, mineral is a geological sense. If you ask any geological person, he says that offering up a chemical compound with or a compound with a single specific composition, that is called a quartz. For geologists, in a sense, if you ask a geologist, he will say the mineral composition in a very single specific composition. At the same time, mineral can be referred also as an inorganic form of nutrients. Naturally, our inorganic fertilizers like MAP, that's a monoammonium phosphates, of most of our agricultural chemicals we use, or agricultural chemical fertilizers we use, they're all called the mineral form. Finally, minerals can broadly meant by the sand, silt, and clay fraction. Especially this, if you ask any pedologist, if he say that, he will give explanation like this: sand, silt, and clay can come. So these are the different words of a meaning for the minerals. And clay minerals, students, clay minerals, it's a type of clay mineral. Fractions of the soil are different than a mineral can be in a coarse fraction. So clay particles is a major is different from the mineral in the coarse fraction. Instead of being round and angular, that is in case of sand particle, clay minerals are very flat, Very flat means not like just our plate or eating plate or something. Somewhat nearly somewhat flat we can see, though you can, that's why the surface area is very more. The size is very less, but the surface area is very more. So more surface area, more negative charge, and more broken edges will be there. So more negative. So there will be a more. So there is a more negative charge concentrated on the broken edges. So the amount of negative charge varies from the different clay particles. That's why you can see in vermiculite it will be something different, in montimolite it will be something different, and some other minerals it will be different. And mostly students, before going to the clay mineral or before going to the another next slides, we have to know the two important topics called absorb or adsorb. Absorb, taking the part and making the part itself. So absorb means it will take itself, it will take in the integral body of taken making a part of itself. So adsorb means it's nothing but it's just an attachment, cause a gas or liquid or dissolved substance adhere to a thin layer on the surface of the soil. Mostly this adhere here, this reaction we can see
Aditya,
mostly in yes, yes sir.
just a minute. Dear students, don't worry about language. We will also explain in Hindi. And there is a people from entire India, from South India and North India. So and generally, as per our requirement, means as per examination requirement, we are explaining in English. Same we will summarize in Hindi at later on, while ending at the end of the class. So don't worry about that, and just try to means listen whatever the content in English. We'll also explain in Hindi. Continue.
Student actually मेरा हिंदी उतना अच्छा नहीं है. My Hindi is not that much proper. It's not good for a teaching purpose. Anyhow, students, I will try to include Hindi also in middle. Thank you. Anyhow, coming to the next slide. Coming to the next slide, tied to the organic matter, students. Yes, students, this was very important. Organic matter, the fertility status of the fertilized or organic matter, or whatever the decomposed matter, crop residues, microbial matter, or organic matter in various decomposition positions also plays a major role in our fertility status. Because you can see it where most of the organic matter observed on its surface of the plant nutrients. Plant nutrients, mostly the whatever about nitrogen, phosphorus, or all of the major and minor nutrient micronutrients will be held on the organic matters, and will provide a good CEC value for the organic matter on the soil texture. So naturally in organic matter there will be more CEC, as I mentioned in my previous slides. So more CEC, very high CEC, we can get a good nutrient uptake by the crop. That's why most of the problems, if you see in your entire career of BSc, you can see whatever the problem is there in the soil, definitely they will advise go for organic matter because of its high nutritional capacity and high CEC. And coming to the nutrient release in the form of organic matter. So students, if you remember, students, if you go in a practical sense, most of our releasing of organic matter, from organic matter, if you see, the nutrients will release only after the decomposition of some microorganisms, right? So some microorganisms will decompose it finally, and it will release the nutrients. It will release the nutrients to the solution form, and that solution nutrients will be uptaken by our plants or by our crops. So while decomposing, these microorganisms also need some nutrients for their energy buildup or body buildup. So if you add a much high CN ratio nutrient, high CN ratio organic matter, what will you do to decompose those high CN ratio organic material? They use the indigenous, that means whatever the nutrient present in the soil itself they will use. So it will cause a temporary locking or temporary fixing of nutrients by the crop. So that's why we in most of in agriculture practice we use only finely decomposed organic cow dung or whatever the organic matter. We use only those kind of materials only in because of high CN ratio. So there will be a lot of problems. So that's why we won't encourage high CN ratio organic material to add in agriculture crops. So we go for very narrow CN ratio, hardly 10:5 or 15:5 range of CN ratio. We use that kind of CN ratio is only encouraged in our agricultural practices. So that's was expanded in these situations. And also students, this decomposition also
Excuse me,
will
sir.
be, yeah,
Hello. Sir, can you tell us more about CN ratio?
okay.
Like a little brief about CN ratio, what it is.
Yes, yes.
Okay, students, C N ratio. Yeah.
Aditya, see
Yes,
asking
sir.
brief about CN ratio. Little bit means just explain again about CN ratio. Is it Amma? Yes.
Yeah, I got the point. Yeah,
Yeah.
I got the point, students. Naturally, students, if you add, say, for example, if you add any material, take any material like cow dung or sheep droppings or whatever matter of organic nature, it will be very fresh and very complex matter. It will be very complex in structure. So those nutrients can't be taken directly by the crop. It's very difficult. So that's why intermediately these microorganisms will play a major role. So these microorganisms will break down those complex organic matter, which have very pure proteins and some amino acids, everything. It will very complex structure will be there. So to plants can't digest those complex structures. So these microorganisms will break down those complex matter and they release the nutrients from that particular organic matter. This is the normally happening in our soils in the name of called decomposition. Decomposition or composting. Naturally, in artificial we are going for composting. But students, if you see frequently when there is a high CN ratio, for example, if you take best example sawdust, which is completely cellulose containing, or in some paper products, you can encounter with a large CN ratio, sometimes 35:10 or even 40:5. Like that, you can see very large CN ratio. If you add such kind of material to the crop, what will happen to break down that particular material, that sawdust or something? What these microorganisms will do, they also need some energy, they also need some bodybuilding energy, so they also need some nitrogen for their protein buildup, for their body buildup, for their amino acids, for their day-to-day activity. So what they will do to decompose that particular sawdust or that particular organic matter, they will use the native nitrogen. Native nitrogen means whatever the nitrogen present in the soil, they will uptake, that microorganism will uptake. It will take and it will use for its body buildup, and it started decomposing of that particular nutrient. In this case, you can see there will be unavailability of nitrogen or nutrients to the particular crop. You can't expect, because what happened? Whatever the nitrogen or whatever the nutrients are present taken by the microbes, and it is used for its body buildup, and it started doing its decomposition activity. That's why, students, in very first season of the crop, you won't get those nutrients. But for the next season, for the coming season, those nutrients will be released by decomposing of their own bodies. Their own bodies. That means their own microorganisms also will die. From their bodies, the nutrients will be released. That's why, students, we won't add any fresh cow dung or fresh material, freshly or improperly decomposed material. We won't add in the agriculture crops. We add very finely decomposed matter only. This is what the main region of CN ratio, carbon nitrogen ratio. That is nothing but for decomposing 10:4 sources. That's the meaning, 10:5. That this is also influenced by the climatic conditions also. If it is a condition was too cool or too wet or too dry, there will be a delay in releasing, because the temperature source will be very less, and the microorganisms will be dormant, so natural decomposition will be reduced, and also nutrients will not be released. Mostly in spring season or in winter season, you can see we can encounter this problem. Is it clear, students, or need any proper explanation?
Yes, sir. Thank you so much.
Yeah, if you have any questions on CN ratio, you can ask them later on. So this is what I completely explained in this around this 7 or 6 points. Mostly in too cold climates. That's why you may heard in soil science, in very cold climate or winter conditions, the decomposition rate was very less, because of there is no temperature, full of moisture. So it is very difficult to get to go for the decomposition. So it is not usual to see the symptoms. This is what I explained. So you can see mostly it is unusual to see the symptoms in the corn and cereal, corn like corn, baby corns or maize or etc. Cereals following legumes in the spring season, cooler seasons. You can see these problems. And also you can see breakdown of organ plays a major important role in microbial supply also. Even the breaking down of that particular organic matter, it will also supply some micronutrients like boron, manganese, etc. Mostly these are the only, because of cool climate seasons, you can expect some deficiency conditions in cool climate conditions. And pH, students, how the pH will affect the soil fertility. Naturally, students, very weak organic acids, some weak organic acids will be on the, will stabilize the organic matter, will stabilize the organic matter particles as a source of negatively charged. There will be some weak organic acid which always stabilize the organic matter particles. So what will happen means, if these sites are completely affected by the, when pH was very high, when the pH was very high, what will happen? H plus ions will be more. So those ions will be tightly bonded to this organic matter. So naturally, they will, so the availability of nutrients will be hindered. The availability of our microorganisms will be hindered. The pH is very high, sorry, very low. That means around in acid conditions, most of the nutrients are not available because of this I conditions, because of H plus ions will bind the is organic matter conditions. So naturally, we will end up with the deficiency of nutrients in a very low pH condition. That means CS of organic matter is so low. If the H plus ions are counteracted on the organic particles, what will happen? Can't expect any release of nutrients, and that's why we can see in alkali conditions only. We can see alkali conditions, not extreme alkali, around 8 or 9, in between around some 7.9 up to 8, somewhat very hard limit. We can expect some nutrient supply in the pH. So pH will affect like this. And impact of non-nutrition properties. So what will happen? This non-nutrition property means naturally, organic matter will improve the soil properties like water holding capacity. It will maintain the structure, and also it will give some stability to the soil aggregates like that's a natural, and plots are artificial aggregates. So all these things, and breakdown of the organic matter facilitated by the micro provides a glue, and also these microorganisms will provide some glue. They will release some useless substances, some glue substances, which will be held the soil aggregates and which will improve the soil structural conditions, and also will ultimately it will counteract with other soil properties and also improve the soil water holding capacity. And next, held down the insoluble compounds. Naturally, students, what will happen means, especially this reaction we can see in phosphorus. What will happen? Some, especially the phosphorus, will sometimes will go to the fixing with the calcium or calcium phosphorus or magnesium phosphate. This reactions mostly we can see in alkali conditions, and especially in the phosphates, especially in acidic condition, you can see it with the phosphates will go and fix with iron and aluminum oxides. So both these compounds are insoluble. Insoluble means it is not available to the crops. So plants will face some phosphorus deficiencies. So most of some nutrients will be held as insoluble compounds. So this will lead to some problem of insolubility and leads to some nutrient deficiency symptoms, and also fixing with the clays, and some nutrients also will be fixed. Especially this clay lattice structure, when the 2:1, when the clay lattice was expanded, especially this reaction we can see is by one famous name called lattice hole theory. Lattice hole theory means, for example, students, you can see that there is these are the clay lattice structures, and this is a K plus ions. What will happen when it was expanded? When the clay lattice was expanded due to the moisture condition, this potassium will enter in between the interlayer between the potassium. When the moisture was gone, or when the climate was dry, what will happen? The clay lattice was collapsed. That means potassium was fixed in between the clay lattice. So this will leads to the trapping or being trapped by in between the layers. So this will leads to the fixation of the potassium. So this is a major problem in especially this, and after when that's why we can see this extreme drying or extreme wetting, or if we go very extreme wetting or extreme irrigation, what will happen? You can see some leaching losses will be there, and if it's a very dry condition, this is what fixation problem is there. So we should maintain a proper manner, then only we can give a proper nutrition to the crops. And coming to the next slide, and here we go. This is a major. This is finally we are coming to the topic of our interest. And mostly soil nutrient transportation takes place by the three manner in the three ways. One is called the nutrient root interception. It's a very direct contact and mass flow. Another one is called diffusion. And very first we will see the root interception. Root interception is nothing but, students, it is the direct contact with the soil. Direct contact with the soil. So there we can see some nutrition will be transported. Direct contact, we can see around 1% of the soil, and mostly root of the most of the crops occupy about 1% or very less of the soil volume. However, roots takes a easier route to the root. Even this nutrition will be entered through the soil pores or plane of weakness of being between the soil clots. So direct contact will be overall anyhow. Student, this root interception will satisfy and available only about 3% of immobile nutrition only. Will satisfy only about 3% of nutrition. And also students, mycorrhizae, association of mycorrhizae. Mycorrhizae students, it is a very, especially you may heard about the VAM, vascular avascular mycorrhizae, VAM is very important because especially this mycorrhizae will improve the surface area of the root, especially the fibrous root system or small root hairs also will improve the surface area contact of particular soil and will improve the root interception. That means there will be some interception, the nutrition will directly come in contact with the root surface and will enter through the root pores. And this mycorrhizae, what will happen means this mycorrhizae will improve the root surface area because of this mycorrhizae have some Eiffel. Say for example, if you want to give any small explanation, just imagine here I'm drawing. Just imagine this is a root, and mycorrhizae was making an host, some symbiotic association. You know what is the meaning of mutual understanding. So what will happen means it will have some hyphal growth. Some hyphal growth will be there. So this will extend it to every corner of the soil. Almost it will improve the surface area of particular root and improve the nutrient absorption through this mechanism. That's called root interception. Mostly, and also students, and also students in root, in every part it won't take. If you see in this image, see students, in the wherever the root hairs are there, you can see there is a rapid entry. There will be a rapid entry of the nutrients. How? Why? Because of increasing absorption surface area. Just now I said there is a more surface area. That's why root hairs at least last for 2-3. That means it should have up to age of 2 to 7 days. And low permeability we can see in root cap tip. In the root cap tip, you can see very less absorption, and we can see some here in this place we can see very active cell growth but very little water uptake. And even upper portion also water very slowly, we can see very slowly will be nutrient will be taken place. Only in the root head surface area you can expect some very good absorption. Also some gelatinous materials released by the cells. Cells also will improve the soil particle adhering. That means attaching of soil particles also will attach the soil particles and improve surface area, and we can get some nutrition uptake. This is the major importance of the root adhesions. And mucilage particles I explained, just like the extraction of mucilage particles, we can plays an important role in uptake of phosphorus and micronutrients. Also some stimulant activity of it is some exudation, some secretions of the roots. You can get some microbial activity in the root zone, and which increases the nutrient cycling and availability of relative surrounding bulk of the soil. So naturally what happened means students, some mucilage substance, some gelatinous substance will be released by the roots. What will happen? It will attract the microbial activity or improve the microbial activity, and then those microbial activity will take care of the extending of surface area by their hyphal growth. This is the major importance of root interception. And another students, mass flow is completely taken place by the transpiration students. If there is a more temperature, the nutrients will be moved through the body, and the nutrients move through the body, and the nutrition during this transpiration, what will happen means some nutrients also will move towards the body part, and it will supply the nutrients to the rest all particles. So this is especially the prime mode of nutrients. Mostly we can see nitrates, chlorides, boron, calcium, magnesium. We can mass mostly plays a major role, especially active in the greater transpiration flow. If there is a more transpiration flow, and there will be a more nutrients uptake. Well, that's why there is one beauty of word called transfer. The transpiration, there is an important word called necessary evil. So transpiration is needed, but also it's also an evil, but it's a very necessary evil. And this uptake of this is what was explained in this complete slide. We have a more transpiration, the mass flow of nutrients also will take some place. And diffusion students, diffusion, it is nothing but whenever the particular nutrients. So for example students, here this is the root surface area. What will happen? say some nutrient, whatever the nutrients, whatever positive or cation ion will enter into the root. What will happen? The root will uptake and use for its body activity. But here the concentration will be reduces because it automatically will move to the some other body parts. There will be some gradient, there will be some difference will be happen. So whatever the nutrients are there, it will take and it will be uptake by the crop. So the concentration is very high here in soil solution, and the concentration of nutrients are very less in the root. So what will happen? What is the basic principle of diffusion? Higher concentration to lower concentration. So naturally in root, the concentration of nutrients are very less, and the concentration of nutrients in the soil solution is very high. So the nutrients will be moved from higher concentration to lower concentration, and this will satisfy the fertility or nutrient satisfaction to the particular crop or nutrient. So this is regarding about the diffusion. At the same time, students, it will completely influenced by the many factors. Students, especially soil moisture condition will be increases. It will influence by soil moisture, soil texture, and many other soil physical and chemical characteristics also will improve more, will influenced by this diffusion. Diffusion will be influenced by these soil moisture, soil textural characteristics, and also students, major nutrients will be transported by diffusion is phosphorus and potassium. Remember, students, this is very important. Phosphorus and potassium will be majorly transported through to diffusion only, and some research studies, especially in Lincoln University, they have said that research studies that nutrition, if a nitrogen travel for 1 centimeter, potassium travel to 0.2 centimeters, and phosphorus travel around 0.02 centimeters in this diffusion process. Like this, students, and also if the roots are very small diameter is there, means natural small diameter is there, means there will be diffusion rate is also very more. So the efficiency of uptake of nutrient in the fibrous root, and the fibrous root, that root hairs is very high. But here, like that, students, and also, and phosphorus extraction, if we go for phosphorus extraction, the root hairs, you can see 90% of phosphorus was held in the root surface area. And also root hair and length increase generally in soils low in phosphorus. Naturally, if there is a phosphorus was very less in particular soil, generally the search for the phosphorus is very high. Then in that particular area, you can see the head density or the root density or the sideward roots are very high. So this is regarding with the diffusion and plant uptake of nutrition, students. Mostly students, some news actually I'm going to explain in next slide. You will get some clarity regarding with these slides, and most of the nutrients will be transported in the plant body in the two mechanisms called a passive and active mechanism. In passive mechanism, you don't need of any energy consumption or energy expenditure, but at the same time for the metabolic activity, that is a active transport system. So in active transport system, we need some energy. In passive system, need of any energy. Movement of ions in the plant cells in the liquid film. So naturally, there will be some liquid film. This film lining will be there in between the cells. So that will provide a space for the cells, and also some ions like potassium, magnesium take along with the negative charged cells of the roots, so it will move away. So like this, you can see some uptake of nutrients will be there, and also there will be you will get next clarity here. Like this, students, in xylem, mostly in xylem, you can see some nutrient. There will be one-way path, almost hollow tube that carries water and nutrients to the plant. Naturally, it will take only water to the particular one, but in phloem we can see both way conducting. So you can see some both way of conducting, and also some in ions irrigation water. You can see some foliage, even for the foliage, the leaves also will plays a major role. It will also observe the nutrients from the leaf foliage, and not only from roots. And another alternate method is from foliage also. You can expect some alternative nutrient pathway. At the same time, student nutrient mobility, especially students in nutrient mobility, there are two types of mobility nutrients are there. One is called mobile nutrient, another one is called immobile nutrient. So based on this concept only, we can understand the nutrient status, or the deficiency conditions of that particular crop. And in the next slide, we will see this. You will see what is there. This is what students, various students, more plant nutrients are completely classified into three ways. Very first one is called primary nutrients, and second is called secondary nutrients, and very finally it is called micronutrients. Students, in soil, the mobility in the soil and plant is completely varies. So for nitrogen in soil, it is medium. where ammonium ions are in soil, it is very medium. Nitrate ion movement is very high. Why means here medium is because it is a positively charged. So clay particles is negatively charged. So there will be some attachment. That's why it's a movement in soil is very medium. But whereas in both are negatively charged, that's why there will be some leaching loss will be there. That's why the nitrate ion movement in the soil is very high. In plant, both form of nitrogen or movement is very high. Both ammonium ion and nitrate ion both are very high. But coming to the phosphorus, in soil it is very low. In soil it is very low because it's completely pH dependent. But in plant it is very high. In plant is very high. And coming to the potassium, is low to medium, students. Potassium is very tricky element. We can't expect how it will behave here. Potassium is in soil it moves up to the low and medium. And coming to the plant, it is in movement in plant is very high. It's very high. At the same time, secondary ions. In secondary ions, we can see calcium, magnesium, and sulfur. And calcium and magnesium, sulfur. And calcium, we can see the movement in soil is very low. Magnesium also is very low. Both are in form of divalent ions, 2 plus. In plant, you can see mobility is very high. In plant, calcium mobility is very high. Magnesium mobility, sorry, in calcium mobility is very low in plants. Magnesium is high. Whereas coming to the sulfur, in soil, the movement is very medium. And coming to the plant, it is low to medium. Students, please remember this medium, high, low, medium. This is very important. You may definitely will get some questions in your final examination. And coming to the micronutrients, boron, chlorine, copper, iron, manganese, molybdenum, and zinc. You can see in soil, boron is high, movement. When I'm talking about movement, mobility, boron is high, chlorine is high, copper is low, iron is low, manganese is low, molybdenum low to medium, and zinc is low. These are the form under which form it will take. These are the forms, some ionic, almost all are in ionic form. Boric acid will take in boric ions and boric acid form. And coming to the mobility, this boron is low to medium, and chlorine is high, and copper is movement in plant. Students, this movement in plant, it is copper is low, iron is low, manganese is low, molybdenum medium to high, zinc is low. Zinc is both in soil and plant. The mobility or movement is very low. This is very important. This slide is very important, student. Definitely will get at least 1 or 2 questions you will get. So please focus on this important. This is very important slide. Coming to the next, students, here we come with the plant nutrition importance. And up to last slide, we have completed out the uptake of nutrition, and we have discussed some important factors like C, pH, and some important concept of mobility, etc. We have discussed all those things. And now from hereafter, we will discuss about the plant nutrition. That means what are the important functions of the nutrients in a particular crop, and what are the scientists who have proposed the importance of plant nutrition, etc. We'll discuss all those things. So is there any questions in the previous slides we can ask? And after that, we can come to this next session of plant nutrition. Any questions, students?
Excuse me, sir.
Yes.
Sir, can you tell us about phosphorus fixation? Actually, I didn't got it when you just made us clear that point.
Yes, yeah, actually phosphorus, actually if you see, sorry, is the best slide to explain to you. Just remember, phosphorus is it will available only at nearly it's available only at neutral pH, almost around 7 point in between 7 to 7.1 or 2, in between 7.5 hardly. You can classify around 7.5, 7 to 7.5. It will available. Okay, so, okay, ma. Up to only 7 and 7.5, it is availability of phosphorus will be there. Some literature citing that around 6 to 7.5 as different. In general, it is available at around 7.5 up to 7.5. So what will happen means, when there is a pH drop, when there is a high pH around, if the pH has gone to the 4 or 5, what will happen? The aluminum concentration is very high. Aluminum concentration is very high. Iron concentration will be increases because of acidic nature of the particular soil, because pH was very less. So what will happen means, this phosphorus will go and fix with this particular iron and aluminum. What will happen? The phosphorus is converted to aluminum phosphates, iron phosphates. So these aluminum and iron phosphates are insoluble in the soil or in soil solution. So insolubility means there is no uptake of crop. So if there is no uptake, naturally plant or crop will face some phosphorus deficiency. This is regarding in acidic soil conditions. Mostly acidic soils you can found in high elevated areas, especially in northeastern areas and some most of parts of Odisha. Coming to the alkali conditions, where the pH was around 7 to 8, up to extent of 8.5. Hardly if you go to the Kerala districts, some area called around where some research findings are saying that they have seen up to 9.5. So those alkali conditions, what will happen means that there will be increasing of calcium and magnesium. Alkalic in nature will increase the availability of calcium and magnesium. So this phosphorus, what will happen? It will go and fix with calcium and magnesium. So it will form calcium phosphates and magnesium phosphates. So this calcium and magnesium phosphate also insoluble. So this is also not soluble in particular soil solution. So what will happen? Availability of phosphorus is very less. That's why the pH, particularly for phosphorus, pH is plays a major role. It's very important, very important. pH was very plays major importance. Both in alkali conditions, go and fix with calcium and magnesium. In acidic conditions, we can say it will fix with aluminum and iron conditions.
Okay, sir. So, sir, how we can fix that problem? Matlab, how can we avoid the phosphorus fixation in our soils?
Yeah, naturally, just we have to manage the pH. If you see in acidic conditions, especially in way high elevated, what they will do, they will apply the gypsum. They will apply the gypsum. So the gypsum, by applying gypsum, naturally what will happen? The pH will be increases. It will replace that acidic area will be replaced by the calcium. So naturally the pH will be stabilized. It comes up to the 6 or 7. So then the solubility will be released. The fixation of phosphorus from that iron aluminum will be released, and this phosphorus will be dissolved in a soil solution, and it will be taken place. At the same time, here also, in coming to alkali conditions also, we have to go for application of some sort of organic material, or we can go for some acidic matter, spent wash or something. We can go there by using all those by stabilizing phosphorus from high degree, from 8 to, we have to bring at least to 7.5. Then the insolubility will be released. The phosphorus uptake will be carry on naturally. After the phosphorus availability, there is a ample supply of phosphorus will be there.
Okay, sir. Thank you so much.
Yeah. Well, I think any questions is expected.
Hello, sir.
Yes.
The gypsum is mainly applied to alkaline soil to what's the
I'm sorry.
and in case of acidic
Okay,
soil,
yes. You made an
yes,
input,
sir.
sir. Sorry,
And
ma.
in
Sorry.
acidic soil, we apply lime, sir.
Yes. I'm sorry. Yeah, it's a vice versa.
Yes,
Swagata,
sir.
Yes.
1 minute. Swagata, your voice is breaking. You will text in chat box your whatever query question.
Yes, ma. I just am confused. It is reverse, students. Lime is applied here, gypsum is applied
Yes,
in alkali.
yes, sir.
I'm something happened like that. Any questions, students? Thank you for correction. Hope okay. We are running out of time anyway. I will continue my lecture in history behind the plant nutrition. Regarding, we can see the history behind. We have talked many things. We have discussed many things about the CN ratio, C, pH, etc. Anyhow, but we will see the real background of the plant nutrition. Specialist Theodore de Saussure in 1804 and Jean Baptiste in 1834 discovered the need of mineral nutrition for the plant growth and development. These two people have proposed the importance of the plant growth and development of the mineral nutrition. And also a German chemist called Justus van Liebig showed the growth and from plant obtained mineral nutrition from the soil. And also, students, Justus van Liebig proposed a famous theory in soil nutrition called law of minimum. And also, so due to this reason, he was considered as the father of agricultural chemistry. Remember this word, you may get in exam. Justus van Liebig, father of agricultural chemistry. This is a short history. And totally, students, for the plant requirement in periodic table, how many elements are there? Recently, they have many elements. I think more than 120, 125. They recently had many elements. So we have more than 120, more elements were added in the periodic table. It is not 1 or 18. There are more than 120. And also, element observed by the plants are almost more or less around 90, less than 90. And essential plant nutritions around 17, almost very essential plant nutrients are 70. In that, functional elements are around 4 are there. And based on this, Onan and Stout in 1939 proposed an important famous theory called essential criteria of essentiality. And later they faced some problem in the essentials of criteria. And another famous scientist called D.J. Nicholas came and proposed another theorem called functional element or metabolic nutrition. And he given with citing some examples of sodium and silicon, CO and vanadium V. Yes, students, Arnold and Stout, very famous theory. This is they have given three important proposals regarding with nutrition. Very first one is called an element is considered essential. Lack of elements stop the plant growth and reproduction. Actually, very first, it's very self-explanatory. When there is element is less, there is no growth. Simply. Second one, element is directly involved in the plant process. That means it will involve directly. It will involve in the metabolic process of the particular crop. This is the second point they have mentioned. And coming to the third one, shortage of chemical element can only correct by supplying of that particular element. Naturally, students, if there is a phosphorus deficiency or there is a potassium deficiency, we can satisfy those deficiency only that particular deficient element only. This is what the three proposed by the Arnold and Stout in 1935 proposed. This is called as a criteria of essentiality. Very important theory. Coming to the next one, students, there are some limitations. Anyhow, by seeing all those three characteristics, it's very interesting and very satisfied. But students, though there is some importance, there is some limitations in Arnold criteria. So what will happen? He said in very third point, we can't replace the deficiency of pyrazide. Sorry, in second point, we can't replace deficiency of another. But there is a chance. Beryllium can be replaced by chlorine. Ru can be replaced by potassium for Ru, rubidium, and vanadium for molybdenum, etc. In such cases, in such cases, by replacing this, if it's satisfied by this situation, the essentiality of potassium, rubidium, calcium, strontium, and vanadium and molybdenum can't be decided. So this is one of the problem faced in the limitations of the Arnold's criteria. Whereas in next, essential plant nutrition. To overcome all these things, plants were classified into as essential plant nutrients. So totally, students, there are 17 essential nutrients are there. In that, 3 macronutrients from the atmosphere. From atmosphere, we can get the 3 macronutrients that is called the carbon, hydrogen, oxygen. See, all these 3 are coming from atmosphere. There is no nutrients. And also there are the 14 nutrients from the soil. In that 14 nutrition from the soil, this from atmosphere, natural cause, 14 nutrients from the soil, 3 are primary nutrients. They consider as NPK, very important in agriculture: nitrogen, phosphorus, and potassium. And coming to the secondary nutrients of the calcium nutrients. And coming to the final one, 8 micronutrients: iron, magnesium, zinc, copper, boron, molybdenum, chlorine, and nickel. So these are the 8 micronutrients. And finally, there is another situation is there is a beneficial nutrients which is need of very less, but they're somewhat beneficial in the uptake of other elements like sodium, silicon, cobalt, and vanadium. So these are the beneficial nutrients in there. So this is the essential plant nutrition. So keep remember, this is a very fundamental. Based on this, we are going to learn many things. So students, there are some indicator plants are there for sodium, sugar beet, cobalt is legumes. It will respond very nice. Indicator nothing but this will be the response of from this particular nutrient will respond. This crop will respond very. That is the cobalt is legumes and vanadium from mushrooms. So leafy vegetables. Silicon is for rice. Naturally, is a very essential. These are called the essential important nutrients. That is called functional nutrients. All the functional nutrients, and this is what the historical background of nutrients. Actually, carbon, G-SOD, and especially we will see only very few students. Our important nutrients are N, P, K. So N, nitrogen was discovered by the Rutherford, and Spinger, there is another person called very important person. Calcium is around Islam Haberman, and magnesium is called the Will Stantner, and sulfur is from Peterson. Like this, the many scientists have given. This is the principal form. This is the year of discovery. This is the year of essentiality. So it is not fair to read all these names here. So these are the scientists who have discovered this particular nutrients. These are the form of nutrients, and these are the year of nutrients which are discovered. For our little cause of explanation, for nitrogen was discovered in 1872, and phosphorus in 1903, and potassium is 1890. So these are the essential were discovered by the particular famous scientists. And which form of nutrients are taken? Mostly these are the forms. Please, if you're taking notes, please note down this. Potassium was observed in single form, and in the single form of nutrients, these are in the combined form, especially nitrogen and it is a ammonia and nitrate form. You can see in phosphorus also because there are the 2 forms, And boron, we can see very multiple forms are there, and 4 forms are there. Molybdenum also is there, carbon, nitrogen, all are observed in combined forms. But here, major part of the nutrients are observed in a single nutrient, and that is called potassium, calcium, magnesium, iron, manganese, copper, zinc, chlorine, silicon, cobalt, and sodium. These are the single form of nutrients. Just take down a note of this. And anyhow, students, we will discuss something about micronutrient needy macronutrients, not micro, macronutrient are needy in concentration of 1000 picogram per gram of dry matter and more. And also, whereas coming to the micronutrient, very trace relevant, very small, with need of very less, and need in tissue concentration equal to less than 100 picogram per gram of dry matter. And mostly these are considered, and there are two kinds of primary and secondary, as explained very well. These are the macronutrients, and because these are secondary, these are the micronutrients, which I have explained. And finally, Mingle and Krigbear in 1978 classified based on their biochemical activity and physiological functions. And there's another type of classification based on the physiological and biological biochemical behavior. They were classified into 4 forms. One is called the group 1, group 2, group 3, group 4. In group 1, you can see carbon, hydrogen, oxygen, and nitrogen, sulfur. The major constituents of the organic material involved in enzymatic process, we can see in oxidation. And phosphorus, boron involved in the energy transferring. And coming to the potassium and magnesium, manganese, chlorine, and nickel, this plays a major important ionic balance and enzymatic, some specific enzymatic catalyzation and osmotic balance will be carried out by this group 3 nutrients. And group 4, you can see some chelating materials like iron, copper, zinc, molybdenum. So this will be these nutrients. This group 4 nutrients will help in chelating of metalloproteins. So this iron, zinc, and molybdenum will play a major role in structural chelator matter. These nutrients will form chelates. Some combinations, some compounds will form in the group 4 matters. Coming to the nutrients that are based on ionic form. So there is another classification called based on ions. And cations, we can see ammonium, calcium, magnesium, potassium, copper, iron, manganese, zinc, and nickel. And with the anion conditions, is nitrate, phosphate and phosphates, both phosphates, and sulfur, boron, molybdenum, chlorine. And in metallic forms, you can see the potassium, calcium, magnesium, iron, manganese, zinc, and copper. Non-metals, we can see NP, nitrogen, phosphorus, sulfur, boron, molybdenum, and chlorine. This is another type, another classification. So remember all classifications, students. If you remember all classifications, but it is very easy for your understanding. Coming to the next, some terminologies in plant nutrition. We can see where regularly we may encounter these words called deficit, insufficient, toxic, and excessive. So naturally, we have here you may encounter these 4 characteristics in while reading in fertility courses. Especially, very first we will see deficit. What is the definition of this? Availability is at very low. You can see here it's a low concentration that serves as a yield will be limit and produces distinct symptoms. So availability of nutrients are very less, further leads to the death of the plant. Naturally, in deficit conditions, what will happen means availability of nutrient use or efficiency is very less. So naturally, the availability of nutrients is very less, yield will be reduced, with showing some distinct symptoms. That is called the deficit. Whereas coming to the insufficient, here it is required optimum yield. Insufficient means the requirement, or when there will be some imbalance with other nutrients also. Here also in insufficiency also they can face some. There will be requiring optimum yield will be when its requirement will be very less. Here also you can see some symptoms are currently rarely observed. You can see during this insufficiency or insufficient, there is some imbalance with other nutrition in simple word. But coming to the toxin conditions, what will happen means is nothing but is a very extreme several result to the death of the plant. Sufficient, it is very high concentration. The availability of nutrients is very high. That's why it leads to the death of the plant. When excessive, it's nothing but it's a high, which is the nutrients will be high, but not up to the toxic level. The availability is very result to the corresponding shortage to the another nutrient. What will happen means some nutrients will be very high, and this due to this high nature of this particular one nutrient will lead to deficiency of another nutrient. Especially you can see that this is called the antagonistic effect, students. Especially if there is a high nutrients of iron, especially the phosphorus uptake will be very less. So this is called the antagonistic effect. So there is two types of terminology is that antagonistic effect, and another is called the synergistic effect. The antagonistic effect, we can see it is vice versa. If one nutrient is very high, the uptake of other nutrient will be hindered. But in synergistic effect, we can see if one nutrient is very high, there will be automatically uptake of another nutrient also is very high. This is called the synergistic and antagonistic effect. And naturally, students, there is a Lebesgue's law of minimum. What he says means growth is directed not only to the total resource available, but the limiting factor or scarce resources. It's called the barrel concept. So what Lieberg says, growth is dedicated not to the total resources of available, but it's limiting factor of the scarce limited. See, barrel concept means if all nutrients are there, we have zinc, we have calcium, we have boron, we have magnesium, we have iron, everything, but one nutrient was very less. What will happen? The water was came out. That means the yield was reduced. This is what explained by this is called the barrel analog, explained by the law of minimum action. So even if there is a requirement of nutrients available for our plant, they won't able to grow if you don't have water. Any single factor. If you provide all nutrients, and here in image I'm showing potassium. So suppose water itself we have not provided, what will happen? There will be a reduction in the yield. This is called the barrel analog and proposed given by the Lieberg. The criteria is considered too rigid for the practical point of naturally some there is some naturally from practical point of view we can't satisfy this barrel and all. Sodium is considered to be non-essential. However, it increases the yield of several crops. Therefore, sodium is an essential. Naturally, sodium. If we talk about sodium, naturally we have to talk about the problematic cells. But this particular sodium, therefore, sometimes improve the increasing this yield of the several crops. So many crops. So the sodium also is very essential. And also Nicholas, given Nicholas scientist another proposal called the functional element. Functional element that functions the plant metabolism, whether or not in action is specific. So action was very specific, especially the functions will be there, but the action was not specific, especially sodium, cobalt, vanadium. Especially I explained about what is the situation in sodium. Considered as a functional element. So these are the functional elements. They need us. They help in the yield pattern. It will consider it will show some functional importance only, not that much important as compared to other elements. So functional essentiality of the nutrients, you can see here I'm given a lot of list is there. Carbon, you can see you can see the functions. It will form the basic molecular structure. It will form oxygen. It will give the energy or carbon, what like carbon occurs virtual organic compounds or being organisms, and nitrogen plays an ionic imbalance. Nitrogen, it will plays integral part of most of the proteins and nucleic it is integral part of the most of the amino acids and proteins. And phosphorus, it is energy currency, mostly energy transferring takes place in potassium. It plays a major role in our osmotic regulation, osmosis. And calcium plays a major role in cell division. Magnesium is an integral part of the chlorophyll, so naturally it will plays a role in photosynthesis. Sulfur, cell energen, so it will give some pungency order of the particular crops. And coming to the iron, it helps in nitrogen fixation. Zinc, it forms several compounds for dehydrogenase, glutamine, dehydrogenase, and many biochemical reactions. Manganese involves in the oxygen evolving system in phosphorus and phosphate transportation. And copper, we can see constitute of number of important enzymes, including cytochrome oxidation, ascorbic acid oxygen lac, etc. Boron, you can see synthesis of cell wall. So boron plays a major role in cell wall and also in the particularly your pollen germination. Also, it plays a major role in boron. And molybdenum, it is an essential part of nitrate reductase. So chlorine is a essential part of the photosynthesis. Chlorine also in splitting of water molecule. So osmoregulation, chlorine also plays osmoregulation, and it will be helpful in splitting of water molecules. And nickel, it's increasing in the viability and germination percentage of some crops, mostly like barley, etc. We can see importance. So these are the essential part for examination purpose. Students, you just know what is importance. So for example, phosphorus energy currents or energy transfer. For calcium, it is a cell division. Boron plays a major role in cell wall synthesis. So like that, you just remember those keywords are very important for your examination purpose. Coming to the mobility, students, just we have discussed in the very far slide, very long slide, we have discussed about mobility, somewhat limitations. So naturally, this is a repetition of those particular slide. Naturally, highly mobile is the NPK plant. You can see intermediate to low mobile, it's called calcium and magnesium. This is a repetition. So this mobility concept was given by the Bray mobility concept. It's called mostly indicators. What are the mobile nutrients is called biomass, and mostly you can see mobile nutrient uptake. It is on the growth stage. Depend upon the environmental conditions, mobile condition response is very high. So in particular students, mobile nutrients sufficiency cannot be used for the Mobile nutrients. Due to the factors of soil test indicates the total amount of available within the profile, not within the root system or spongy nutrients. And in mobile students, overall students, this mobile nutrients, in mobile nutritions, we can see the symptoms, especially this brain mobility concept. In symptoms, we can see only lower leaves, whereas in mobile, yeah, in immobile nutrients, we can see symptoms in our in upper leaves. This is the major role in to understand mobility deficiency. We can go for this. We can go for this immobile nutrient status. So mostly students nitrates, especially variably mobile and immobile, calcium immobile and mobile. These are the mobile nutritions. These are the variable mobile nutritions and immobile nutritions. These are the immobile. So naturally, students, effect of the nutrient deficiency on plants. Naturally, calcium and magnesium. Please take this important, students. On terminal bud, if the terminal bud was dried, so we can consider that deficiency is calcium and boron. If the younger leaves are shown some symptoms, some drying or some yellowing, you can consider those symptoms are called silica, copper, sulfur, iron, manganese. On older leaves, you can see major, all are immobile, NPK, and manganese, zinc, and molybdenum. You can see some older leaves, you can see the deficiency. So this is a very interesting slide. Please note it down. And finally, we came to nitrogen. It's integral part. Nitrogen is very integral part. It's integral part of the nucleic acids, porphyrin chlorophylls, and porphyrin rings, alkaloids, and some vitamins. And it imparts a green color to the plants. And also, it's a basic unit of the chlorophyll structure, students, in porphyrin structure. So naturally, porphyrin is and also it forms a bonding with magnesium. So nitrogen improves the uptake of P and K, students. So naturally, this is called as synergistic effect. So nitrogen requires a carbon utilization metabolism, and also it plays a major role in nuclear protein and involved in the control of development of hereditary process of DNA. Naturally, in very depth we go is very interesting. If we go very depth, this nitrogen will control the hereditary process of the DNA, and it will improve the uptake of phosphorus and potassium. And coming to the nitrogen deficiencies, what are the deficiencies we can see? We can see deficiency in lower leaves because it is a mobile nutrition. And stunted growth, we can see very stunted growth and yellow and discoloration, leaf tip backgrounds. We can see some B color symptom. We can see like this. We can see some B color symptoms and reduces tillering. We can in cereal crops. We can see there is the reduction in tillage. Yeah, this is what we can see. Tillers are very less. And coming to the toxic symptoms of if you go with the toxic with more concentration, what will happen? Leaves often darker green and early stage of abundance with foliage. Leaving leaves will be dry and begin fall off due to the excess nature. Root system will remain underdeveloped or deteriorate after time. Fruit and flower will set inhibited and deformed because nitrogen will encourage only foliage growth. I mean vegetative growth will be encourages. This is the major problem in toxic symptoms of nitrogen. And coming to the phosphorus, students, phosphorus is energy store. Mostly it will involve in ATP, NADP. It's energy currency, transfer of protein metabolism, and also it is an integral, or it is a hereditary process. In the hereditary process, it is a base pair of the DNA. In DNA, RNA also phosphorus plays a major role. And increase phosphorus is mainly increased in our root growth. Root growth plays a major role in the phosphorus. And also it is also an energy transformation. It plays a major role in cell division. It acts as energy currency, and it also improves the quality. It is a quantity of phosphorus found in the seeds, and it will provide the disease resistance to some extent some crops and enhance the rhizobial activity found in the root nodule. So these are the important functions regarding the phosphorus. And deficiency symptoms, if we come to the deficiency symptoms, these are very familiar. Most of them are very familiar. We can see some phosphorus discoloration in corn crops, not only in crops, even you can see in sorghum. Practically we have seen this side of purple discoloration. These are the images of phosphorus deficiency, students. You can see some purple discoloration. This is the thing. And coming to the toxic symptoms, what will happen here? Naturally, it will if there is high amount of phosphorus, what will happen? The availability of copper will be decreases. Copper and zinc will be decreases. Necrosis of the tip. You can see some dieback symptoms. Necrosis and tip dieback symptoms. We can see some marginal scorching of lower leaves. We can see these are the very important phosphorus deficiency. And coming to the potassium, potassium is the major role is osmotic and ion regulation, students, and also it will provide some disease resistance and active cofactor of many enzymes. Actually, it plays a major enzyme and stomatal movement. And remember, students, potassium is the only element which is not an integral part of the not an integral part of a plant body, but it will act as a policeman. It will control what should be entered, what should not be entered. So naturally, it is called as a policeman in a crop, and also it will regulate the osmotic movement by transpiration. And you can see it will help in translocation of assimilation, and it potash helps in the formation of, it will also help in the formation of synthesis or formation of proteins and chlorophylls, and also it will activate the starch synthesis. It gives a vigor and resistance to the also, and also it will produce a strong and reduce the lodging in cereals, and you can see some hidden hunger phenomena. You can see if the condition that hidden hunger means, students, especially hidden hunger is nothing but there will not be any particular symptoms shown by the crop, but you can see there is a direct reduction of yield. This mostly happen in potassium case because we can't see any particular visual symptoms, but the yield will be reduces. This is called the hidden hunger. So coming to the deficiency of potassium, you can see mottling of leaves, necrotic areas develop at the tip. Mostly you can see this here is the best example. The corners will be dries up, and in advanced case, what will happen? The entire leaf will be reduces. So the corners will be necrotic areas. We can see plant growth was reduced. Internodes are shortened, and also toxic symptoms. If we go over the toxic symptoms, may leads to the magnesium, possibly manganese and zinc iron deficiency. This is called the toxic symptoms. If there is a high amount of potassium, you can see reduction in magnesium, manganese, zinc, and iron deficiency. So excesses. So this is the toxic symptoms of potassium. This is the image called. This is a healthy leaf. This is a potassium deficiency. This is the potassium. Sorry, this is a phosphate deficit. This is a potassium deficit. This is nitrogen deficit. So you can see the difference of deficiency of major nutrients. This thing. And coming to the next functions of calcium. Actually, calcium is the structure. It is a permeable membrane. It's the constant of the cell wall, and also it will improve the stiffness of the plant. It plays a major role in the calcium in the respiration of mitochondria, on organizing chromatin. It plays some stabilizing structures in chromosomal structure, and also help in organizing of chromatin in cell division, mitotic spindle fibers during the cell division. The formation of mitotic spindle fiber and organic chromatin, all this will taking place by the calcium. And also it will go, given the advantage of early root promotion. We can see easily root tips, and there will be a good water economy. That means this is efficiency of water is very high. Improves the uptake of nitrogen. If there is a proper calcium, there is a good uptake of nitrogen. Also affect the translocation of carbohydrates in plants, encourage the seed production. So considered as immobile, it is a very immobile element. So that's why most of the deficiency symptoms we can see shoot tips and root tips we can see. And coming to the calcium, mostly depth of the terminal bud we can see. Mostly you can see blossom and rot and tip hooking are the major famous deficiency symptoms of calcium. Coming to the next one is in cauliflower, you can see this caul-like necrotic hawking, and this is one of the this is a very important deficiency in calcium. Coming to the toxic symptoms, you can see may precipitate the sulfur in solution, causing clotting or reducing the tongue. You can see some precipitations reactions will be taking place. The distinguished visuality is very less. Coming to the magnesium, it is a component of manganese. It's magnesium. Magnesium is the integral part and component of ribosomes, and it plays an important role in binding of ribosome particles during photosynthesis, and will impart the dark color to the leaves. It is the magnesium because it is the integral part of the chlorophyll, forms a polypeptide chain in the albumin forms and forms a chelating forms. It forms chelating, and also it plays a major role in photosynthesis. So because of forming of rubisco, that's carbonase, etc., and plays major role in many physiological and biochemical reactions, and follows. It also helps in the formation of carbohydrates, fats, and vitamins, etc. So magnesium is the mobile element. So its translocation is very from older to younger leaves. It was partly you can see it's a mobile element. As we can see from older to younger leaves, we can see the deficiency we can see in older leaves. So magnesium deficiency, you can see intervariate chlorosis. We can see in cotton, you can see reddish leaves. This is a very regular deficiency we can see in cotton crop. And coming to the manganese, may induce naturally if there is a toxicity. Naturally, the K deficiency you can observe. And coming to the sulfur, it will provide it forms some amino acids, and these are disulfide bonds the polypeptide chains consisting of some vitamins, some biotin, thiamine, and coenzymes. It's an important parts in the coenzyme formation of all this reaction. Also, it imparts some proper what you can say, some aesthetic value. I mean, you can get some smell, some that sulfur. You can so by dial past in onions, we get some smell we get now that is due to the because of the sulfur conditions, and also it will stimulate the seed formation. You can say that there will be a seed formation. It promotes the nodule formation and the visual part of the ferredoxins. So all this will happen. Sulfur synthesis of the chlorophyll naturally. Sulfur will which will encourage this encourage the synthesis of chlorophyll. So coming to the next, the deficiency symptoms. You can see mostly in yellowing of leaves, nitrogen deficiency. You can see veins of pale and yellow inter like this, and occurrence of downdrop cupping of the downward cupping. You can see in tobacco and tea, in sulfur deficiency, and you can see if there is a toxic symptoms, what will happen? There will be a growth of stunted, leaves yellowing and scorching at edges. We can see. Coming to the iron, it's a constant of the pyridoxine, constant of iron, phosphorus, and proteins, and it is a constant of most of the enzymatic systems, helps in carrying out enzymatic reactions. You can see more. You can there. It also plays a major role in enzymatic reactions. The constant of pyridoxine, and actually it plays in most of the photochemical reactions that take in the presence of iron, especially in photosynthesis and biology, especially in biological nitrogen fixation. This iron will plays a major role, students. And mostly you can see ivory white of paddy or leaf bleaching in sugarcane are the famous deficiencies. Consequently, we can see veins remain green and other leaves proportion turns yellow and tending towards the whiteness. So this is another deficiency. Only intervening chlorosis is another famous. So toxicities are conditions. If you see toxicity conditions, you can see mostly in lowland conditions. We can see bronzing of older leaves. You can see and induce the PK, major phosphorus and potassium, and zinc deficiency. You can observe there is a high amount of supply of iron is there. And coming to the manganese, it is the activator of many respiration enzymes, an activator of enzymatic nitrate reactions, and also take a major part in electron transport of photosynthesis, chlorophyll formation, and it influences the oxygen levels of plant. It also supports the movement of iron in plants. It takes part in enzymatic systems like chromatin bonding, RNA polymerase chain reactions. Coming to deficiency of magnesium, the young leaves are affected by the motile chlorosis. Because in motile chlorosis, vein remains, small necrotic spots develop in the leaves. You can see some necrotic leaves, the yellowing strips we can see in particular crop. And because the toxic symptoms, you can see blotchy leaf tissues, it means some dead tissues, chlorophylls, growth rate will be slow and vigor will be declared. Coming to the next, you can see intervening chlorosis. We can just for observation, students, just observe if there is intervening chlorosis in older leaves, that is a deficiency of magnesium. If intervening chlorosis in younger leaves, that is the deficiency of iron. Complete intervening chlorosis, we can see that is a deficiency of manganese. So just remember this difference in chlorosis deficiency to avoid any sort of confusions. But the zinc, it's a growth hormone auxins involving the biosynthesis of growth hormonal enzymes, and also involving several enzyme activating process. Copper mostly is the constant of plastocyanin. Copper it's one of the important protein in particular crop. It also consists of several oxidizing enzymes. It helps in indirect effect on nodule formation, and also it is electron carrier in oxidation reduction reactions in the plant. So copper is the role of copper, and you can see deficiency of zinc. Mostly upper leaves will show chlorosis on midrib, and beans get dead spots, and you can see white bund in maize, and naturally in rice we can see thyroid disease. That's everyone knows, and induces chlorosis, iron chlorosis. If there is toxic symptoms, actually we can expect some iron chlorosis. Deficiency of copper, we can see dieback and little leaf disease in the citrus, and reclamation disease in or white tip disease in most of the legumes and cereal crops. And coming to the copper, reduce the growth followed by symptoms of iron chlorosis, stunting, reduction, branching, abnormal cracking. We can see there is and this elimination essential but extremely toxic in excess. So copper, you can see we need a very less, but if we cross its limit, it is extremely toxic to the crop. So boron facilitates mostly sugar complex. It forms sugar and borate complex. It will involve in the cell differentiation, development of new cells, especially, and also it will import in the pollen germination, etc. We get fruit set, all we can indirectly in fruit set, all these things in boron will plays a major role. In molybdenum, it's the constant of enzymatic nitrate reactions. In chlorine, it is activator and splitting of water molecule. Just I mentioned previously. And nickel, essential for the nitrogen metabolism and grain filling and seed viability. And coming to deficiency of boron, we can see Victel like a Piplex structure. It's called Victel. Brown heart of cabbage and heart root of sugar beet. These are famous deficiencies of boron. Coming to the intervening chlorosis, if there is a toxic symptom, toxic is there, boron, we can see intervening chlorosis. Deficiency symptoms of molybdenum, especially we tell of cabbage, very famous deficiency in cabbage. Molybdenum deficiency, intermittent chlorosis, and formation of is inhibited. So anyhow, and finally coming to the indicator plants, certain plants some gives a very specific symptoms. So those particular crops are called the indicator plants. What are the indicator plants? For nitrogen we can see cauliflower and cabbage. For phosphorus we can see rapeseed. For potassium we can see potato. See potassium, potato. Rhyming is very good. For phosphorus is rapeseed. Nitrogen is calcium and cabbage. In cauliflower you can see, sorry, in cabbage calcium you can see cauliflower and cabbage. Magnesium, potato. Iron, cauliflower and cabbage. Sodium, sugar beet. Manganese, sugar beet and oats and potato. Boron, sunflower. Like this we can see, just for remember students, cauliflower, cabbage are respond to both iron and calcium. Potato, potassium and calcium. This potato crop is respond for both calcium and iron. So remember like this. For boron, you can see sunflower. So these are the indicator plants for the particular element. So these, why indicator of this particular element? It will show very specific and response to very specific symptoms. It will be very specific symptoms and will respond to this particular nutrient very easily. That's why this is called as a indicator plants. So with this long lecture, thank you students. Thank you very much. Is there anyone? Thank you.
Thank you, sir.
Yeah.
Thank you, Aditya.
Shall we go for polling now? It's almost too
Yeah,
delayed.
just you remove this one presentation. Exit
Okay.
from screenshot. That is screen share. Okay.
Yeah.
Thank you, Aditya, and thank you all the students and ACA team members, Devdatta, Megasena, Arif, and all of you. Students, if you need briefing, we will provide briefing now. Yes, anybody please respond if you need briefing. Okay. Otherwise, don't worry. We have a complete faculty. We have in all subjects we have a combo. We have mixed faculty from north and south. So don't worry about language issue. And
Don't worry. From next class, I will try to speak in Hindi.
other than that, as we informed in this text box, chat box, we have in our program we have live classes, then unlimited watchable video classes, recorded video classes. Then we are going to conduct 35 mock tests and 25 grand tests. Same time we also provide magazine for current affairs, and we also cover your general agriculture plus current agriculture plus general knowledge. Friends, you may know that from this time onwards, 2020 onwards, ICR and NTA changed the system of assessment, entire questioning pattern and examination pattern itself. There is no scope for memory based, means remembering of facts, figures, or whatever that. There is completely the examination is based on the concept oriented, and in future it will be increased. The level of concept oriented question will be increased, number of questions. You may know that. This one, what is that? More questions from many subjects this time, like statement type, assertion, and reasoning type. For that, your concept must be clear. So we will work on that way. We will provide guidance on that way. Okay. Other than that, regular classes. We will start regular classes once completion of that subject demo classes. We have another demo class on soil science in next week, I think so. So please attend next class also. Then you will take decision. We are not telling to, and other than this, I will also share two more previous video classes in our group. You go through it. I will send one or two notes material also for sample. You go through it, then you will take decision. Okay. And for the price purpose, we are giving good discount up to this discount applicable up to 15th. Okay. Thank you, students, and thank you, Aditya and ACA team. And same time, I am also specially I want to say thanks to Krishi Kranti team, Agri expert team, then Agri study team, study official team, then Agri GK 2K18, then Agri competitive exams, Agri logic, and Agri exams, Agri competition, and all other our collaborators in Insta, Facebook, and Telegram. Thank you, one and all. And now there is a quiz. I think so. Sorry for I was forgot it. There is a poll of 10 questions. Just answer. Don't leave a mark. Just start poll. Poll regarding this class.
Sorry,
Okay, just someone start poll. Magasan or Aditya. Go ahead.
I'm facing some technical
Next
problems. Please
demo
start
class,
someone
and I
else.
think just someone text Devdatta. Please text.
Please, I'm facing some technical issues. Someone start poll.
Yeah, already started. Going on.
Okay, okay. Just only 5 questions. Very basic questions I have asked.
Aditya, when is the next demo class?
I have to see.
I think next demo class going to going to take care by Magasin, na?
We will inform. We will inform.
So the first question is essentiality criteria for a plant nutrients were outlined by. The correct answer is Arnon and Stout. It's not Arnon and Stewart. The correct answer is Arnon and Stout.
Next demo class on 16th. Yes, next physical science class on 16th. Tomorrow we have demo class on breeding. Second demo class on plant breeding and genetics group, plant science group, that is including pathology. Amma, I sent Lakshmi, I sent messages and links to you. Just check, Amma. I was on the, I think day after yesterday, day before yesterday, 2 days back, I sent when on the day of entomology demo class, I informed you. Just take a check. Already one demo class on entomology is already over. Just please you text me on WhatsApp. I will provide that class.
The next question is phosphorus is absorbed by the plant from soil mostly by the process of. The answer is diffusion.
7569864271. 7569864271 అమ్మా.
The next question is symptom of manganese deficiency. It is actually younger leaves. Correct answer is